All right, so today we're going to talk about quadratics. So this is the first lesson in the quadratic unit. So quadratics is going to be any equation that ends up having a squared in it, meaning something to the power of 2. So it doesn't have anything else higher than that, no other higher powers, it's just x squared. Okay, and then the graph of a quadratic is going to look like a U or an upside down U, okay? No sideways. All right, so these, and you can't go this way. All right, those are different functions. All right, so these are the notes. Just want to walk you through these real quick. So standard form, we have numerous different forms of quadratics. So we're going to start off with the most basic, which is standard form. So standard form of quadratics is y equals ax squared plus bx plus c. All right, so again, we see the squared there. A, B, and C are any number that we want it to be, except for A cannot equal 0. All right, so if A were 0, then it would be 0 times x squared, and so then that would go away and it would no longer be a quadratic. All right, when graphed, a quadratic equation creates a U-shaped curve called a parabola. Okay, now that parabola can either be facing up, like this. And a couple unique things about a parabola is that a parabola is symmetrical, meaning that you can draw a line straight through it and the two sides would be the exact same, like they mirror each other. So think of line symmetry from geometry. All right, so this one points up or opens up because our a value, which is really a 1, we just don't see x, 1 times x squared is just x squared. So that's a positive, so our a value is positive, so therefore the parabola opens up. If the a value is negative, so we have a negative out here, then the parabola is going to open down. So this particular one is going to be kind of like over here. And again, we have a line of symmetry. And this also goes straight through the vertex. Okay, the vertex is what we call the turning point, because it is, so this is increasing, gets to this point and then turns and starts decreasing. So the vertex is where the graph turns and goes the other way. All right, so if A is positive, like the first graph here, then the parabola opens up like a smile. If A is negative, then the parabola opens down like a frown. So this one right here. Okay, so that's helpful. So you can just look at the equation and you know automatically which way the graph should be pointing. All right, the axis of symmetry is this dotted line that I've drawn on both of these. That's a fancy word for our line of symmetry, okay? So the axis of symmetry is the vertical line, and it is always vertical. It's the vertical line that divides the parabola into 2 equal parts. Okay, the formula for axis of symmetry. So just by looking at the equation, we don't know what the axis of symmetry is, but there is a formula for the axis of symmetry, and that is going to be x equals, that's very important because that's the equation of a line. That's a perfectly vertical line on a graph. It starts off as x equals negative b over 2a. Okay, so the vertex is the turning point. Of the parabola. We just said that a minute ago. Okay, so it's kind of like that middle point, again here or here. When the vertex is the lowest point, it is called a minimum. And when the vertex is the highest point, it's called a maximum. All right, so let's go through and let's do a couple examples of these. So this is called, so when the vertex is the low point, would be like this, that's just a minimum, and like this, that would be your maximum. Okay, so axis of symmetry. So to do that, we write out x equals negative b over 2a. But before we do that, let's go over here and let's write out what our a, our b, and our c are. So your a is the number that's with the x squared. So we don't see a number here, so we know that it's 1. The number with just x is your b, so that's positive 8, and then positive 15. All right, so now we're going to fill in the numbers for the letters. So x equals negative 8 over 2 times 1. So this becomes negative 8 divided by 2, which means x equals negative 4. So our axis of symmetry is at x equals negative 4. Now, once you find the axis of symmetry, what's nice about doing this formula is that you're finding two things. You're actually finding the axis of symmetry, and you're also finding the x coordinate of your vertex. So that means my vertex is at negative 4 because, as you see, your axis of symmetry goes through your vertex. So to find the y, we're going to plug in negative 4 back into this original equation right here, wherever we see an x. Okay, so I have y equals, I'm going to put whatever my value is, so negative 4, I'm going to put it in parentheses, times negative 4 plus 15. Now, you can use your graphing calculator and you can plug it in exactly how that's written. Right, so this would be parentheses negative 4 close parentheses squared plus 8 times negative 4 plus 15. Again, always putting in the value we're substituting in for x in parentheses. So that gives us negative 1. So y equals negative 1. So my vertex is at negative 4, negative 1. And then sketch, okay? Based off of my a value is positive, so I know my parabola opens up with a vertex at negative 4, negative 1. Okay, let's do another example. All right, we're going to jump to number 3. So a equals 3, b equals negative 12. So you got to be careful. You got to follow that sign. And c equals 5. So x equals negative b over 2a. So now I'm going to plug in my numbers for b and a. So negative 12 over 2 times 3. So be careful. My b is already negative because it's negative in the equation. So then when I put it into this formula, it's negative 12, which actually turns it to be positive. So we actually have 12 divided by 6 because 2 times 3 is 6. And that gives me 2. So my axis of symmetry is at x equals 2, which means my x coordinate of my vertex starts at 2. So then again, I'm going to go to my calculator and I'm going to plug in 2 wherever I see an x, and I'm going to put it in parentheses. So 3 parentheses 2 close parentheses squared minus 12 parentheses 2 plus 5. And that gives me negative 7. Again, sketch, we look at our a value. If a value is positive, then it goes up with a vertex at 2, negative 7. Okay? All right, one last example. So be careful with 7 and 8. Notice on number 7, we're missing our c value, which doesn't change anything because if you notice, we never really use the c in any of this stuff. But if you look at number 8, notice in number 8 that we're actually missing our b value. So our b value is 0. So when we go in to plug this into our equation here, we have negative 0 over 2 times 1. Well, 0 over anything is always going to be 0. So if your b is 0, your axis of symmetry is always going to be 0, and your vertex is going to start at 0 every single time. And then if we plug 0 back into this equation, you can probably do this faster mentally than you can putting it into the calculator. 0 squared is 0, minus 3 would be negative 3. So again, or whatever we find here, you plug that back in. Plug it back into the original equation that's given. okay? And then that will tell you how to find your y. Again, for the sketch, a is positive, so it goes up with a vertex at 0, -3. Okay, if you have any questions on that, let me know. Thanks.